PrismArch is a unified multidisciplinary design platform where AEC designers can collaborate more freely and effectively, aided by fully integrated interoperability, artificial intelligence, and virtual reality systems. In this video, we will show you two scenarios. One in which a single user works inside the PrismArch environment. Later on, we will show you multiple users collaborating simultaneously. PrismArch utilizes Speckle, an open-source interoperability and data storage platform that was developed for the AEC industry. To begin working in PrismArch, we must therefore connect to a specific project called a stream in the Speckle system. The platform greets first-time users with a personalization area where they log in and manage settings to initiate their personal worksphere. We can also adjust graphical and language preferences and select an avatar previously created in the Ready Player Me interface. Additionally, users can refer to the PrismArch documentation. Once everything is set, we are ready to proceed into the worksphere. To view a project we want to work on, we open the Project Selection tool within Metadata on the control panel. Different projects appear as pins corresponding to their geolocation on a globe. When we select a title, project files and 3D elements are loaded into the metadata for future queries. We can import project critical information into the worksphere using the PrismArch Query tool or File Explorer. The Query tool allows us to browse and select from all the files previously uploaded into a project. The File Explorer allows us to import files saved locally on our computer into the PrismArch environment. Using these tools, images such as conceptual sketches or site photographs can be imported and displayed in the current worksphere. Users can also import PDF files. All of these 2D assets can be moved, scaled, and rearranged within the space to create immersive 3D presentations. Let's now import some 3D assets into the worksphere. Users can browse and import models previously uploaded into the PrismArch environment. Each one is tagged with their author, upload date, and software source. We can view multiple models simultaneously. For example, the user might wish to load and compare different design options, or they might want to load and overlay models from different parties on the project, such as the architect, structural engineer, and MEP engineer. Just like the 2D assets, each of these models can be individually manipulated, moved, rotated, or scaled with their bounding box. By coordinating these 2D and 3D assets within the worksphere, users create an engaging and informative design environment. For closer examination, we can pin one or more of these models onto the display table to view them from a bird's-eye perspective. Once loaded onto the table, these aligned models can also be rotated, scaled, and moved. PrismArch contains several intuitive design tools, such as the clipping tool shown here. This hides a portion of the model from view. Now we're going to jump into the model to explore it at 1:1 scale. Users can move the pin to select a location and then select the pin to enter the model. Inside the model, We can teleport from one location to another to understand the spatial characteristics in VR. This makes it easy to visualize the design and identify potential problems. Users can adjust the time of day and date of the year, simulating real-world lighting and shadow positions. We use the tracing paper tool to trace, draw shapes, and record markups to assist the design evaluation process. There are several different drawing styles: pen, brush, lines, etc. We can also adjust the size and color of these tracings to ensure that annotations stand out. Inside the one-to-one space, we can also select objects and assign comments to provide specific feedback for other collaborators. PrismArch is tightly integrated with Speckle's open-source interoperability platform. Users can export 3D assets prepared in a range of standard AEC packages such as Revit, Rhino, SAP, and Blender, and import them seamlessly into PrismArch. Here, we're exporting a detailed architectural model made in Rhino. We can use the Speckle web-based interface to check the models we have uploaded and preview them in 3D. All of these models uploaded into the Speckle system are then accessible inside PrismArch. Alternatively, users can import locally saved models directly into PrismArch using the File Explorer. Once fully loaded, we can move these assets to different positions and examine them from various angles. PrismArch also provides design tools that allow us to create elements from scratch, like curves, shapes, or simple 3D geometries. We can rotate, scale, and move these newly created assets to illustrate design intentions. In this scenario, we're inserting a basic volume to test massing options for a building extension. Once we're happy with the design, we can save and upload the elements to make them accessible to other team members and ensure that changes are tracked over time. All saved data is automatically tagged with the user, their organization, and the date created. However, we can also assign additional tags to the saved objects, such as project typology, materials used, and so on. Whilst inside the one-to-one space, users can return to the worksphere at any time through the wrist control panel. Any elements created at one-to-one scale can be reloaded and viewed in the worksphere. Regardless of how they're repositioned or scaled in this sphere, their real-world coordinates and scale are retained so that the geometries always appear where they were saved when viewed again in one-to-one scale. PrismArch allows multiple users to work together in real time, regardless of physical location. The platform facilitates collaborative design in its collective worksphere, where we can interact with other users, share ideas, and give feedback. All of the tools previously demonstrated in the personal worksphere can also be used in this multi-user environment. This results in a collaborative, immersive information space that is crucial for knowledge exchange and multi-author workflows within AEC. We have developed an AI design assistance tool for architects and engineers to explore the solution space effectively during conceptual design stages. The example shown here generates multiple layout options from predefined inputs, such as room sizes and connections between them. We follow an iterative process to refine the design results to satisfy our criteria. The foundations of this AI design assistance tool are a combination of quality, diversity, evolutionary algorithms, and continuously updated designer models that capture designer preferences. This allows for effective exploration of design solutions, leading to more diverse designs and faster decision-making. PrismArch leverages real-time technologies to de-silo the AEC development pipeline, allowing architects, structural engineers, and MEP engineers to interact and design together in real time within a single VR-optimized environment.